The axis of evil is a term that's bled into physics from American history. It refers to one of the mysteries surrounding the world's most ambitious map, that of the cosmic microwave background. The Wilkinson CMB WMAP is a beautiful round map dressed primarily, and like the Earth, in blues and greens. They hold small buds of warm colors spread all throughout. The spotted mottled hues seem to have no real pattern to them. They represent the radiation swarming around the universe just 380,000 years after the Big Bang, when the temperature was 3000 degrees Kelvin. The image is a relic. Each successive attempt at mapping the CMB has given us a finer resolution, sometimes confirming our expectations and at other times presenting us with lingering mysteries that continue to come up no matter how detailed our maps become. Perhaps the most famous and controversial mystery is that of the cold spot. Researchers believed the mystery would be resolved with the collection of Planck's high-resolution data, but instead the anomaly persisted. Research in the last few years has proven that the cold spot hasn't only remained, it's also gotten much more peculiar. According to physicists involved in the study, it may be that our most outrageous theory is the one that'll solve the glaring mystery of the cold spot. The spot in question lives in the bottom corner, just to the right of the axis of evil. The axis is a line that snakes across the map and divides it into two sections with very different temperatures. In fact, the CMB is colder above our solar system and warmer beneath it. Temperatures across the CMB do vary by tiny amounts, but these variations should be random. Instead, the axis shows that they form a pattern where sides of the CMB have distinct temperatures, one colder and one warmer. It's not a pattern which should exist according to our universe's standard model. Scientists believe the axis to be a result of how we incorporate inflation into our model of the universe. Inflation should have occurred in all directions equally, but it could have a preference for one side, expanding more that way than the other. The cold spot lies then, like a great island or mirage, in the hot hemisphere of the CMB. It spans 30 degrees total and is 4 times colder than expected. This translates to a 0.00007 K temperature drop, an amount we would find negligible, yet the chances of this being a random quirk of our universe are just 1 in 50. We thought the mystery had been resolved in 2015 with a convincing idea. A supervoid could exist in the direction of the constellation of Eridanus. Supervoids cause temperature drops because CMB photons entering a void lose energy. This energy is regained when leaving the void, but, because of the expansion of the universe, the photons must travel farther and end up leaving with less energy, making that region look colder on the map. This is the integrated Sachs-Wolf (ISW) effect. 6 years ago, just such a supervoid was found. This Eridanus void was a mostly empty gap, holding sparse galaxies and not much matter at all. At 1.8 billion light-years across, the giant would have been the largest void discovered to date. But a more recent survey into the cold spot revealed there wasn't just one massive void in space. There were 3 of them, smaller, closer, and a bit older than the original 2015 supervoid. Altogether they were enough to drop the temperature by 9 microkelvin, but not by the 70 microkelvin needed to explain the cold spot. All 3 mini-voids couldn't account for what we were seeing. For comparison, the new 7000 Galaxy survey included a control group in the form of a separate slice of sky with a similar void density to that of the cold spot. But there was no cold spot there. Why should the same number of voids create a blatant anomaly in one part of the map but not the other? This was enough to convince many researchers that the cold spot was still special. It couldn't be explained away so easily, but rather persists and grows more achingly present with our every attempt at mapping this relic radiation. While some researchers continued supporting the void idea, physicist Tom Shanks summarized the growing uncertainty in a simple sentence: the paradox is that the craziest sounding of the exotic models for the explanation of the cold spot is actually the most standard in terms of the inflation model. This exotic idea is that of parallel universes. If there exists somewhere a universe much like ours, floating along in space-time, a spectacular orb with galaxies on its skin and bizarre new planets soaking in the light of their stars, it could have bumped into our own universe and left a bruise. just a touch between two worlds. The collision would have left a polarization signal, or what we call the cold spot. This polarization signal, if there, will become more apparent as we continue to analyze data from spacecraft like ESA's Planck. The parallel universe theory is one which continues to crop up and be dismissed time and again in physics. It's certainly a wild and fantastical idea. Yet it's implied by quantum mechanics, inflation, and string theory. It's a mathematical possibility which tries to fit itself into physical reality, and yet we aren't sure whether it can. Now, or ever. But even if this other world does exist and we did bump into it, what are the chances that we'd be in a perfect location to see this cosmic mark on our maps? A more modest solution to the cold spot is that our universe is just imperfect. Like our own bodies, maybe the CMB has a defect stemming from the early universe's fiery, changing past. During a phase transition it could have caused a defect which we see now as an unsettling blue cold spot on the CMB. However, inflation should have smoothed this over. Whatever it is that's causing the cold spot, it seems to be saying that we're missing something. A better standard model, a better incorporation of inflation, a more open mind towards the possibility of parallel worlds. It's an aching bruise not only on our maps, but on our scientific theories. One day we hope to understand how it came to be. A scrape from the universe's early childhood, or an encounter with another floating cosmos?